Hi students, welcome to the science class. In last session, we discussed about some of the separation methods of the mixtures that are nothing but separation by evaporation method, separation by that is we are going to take centrifugation method, and also consider separation of the mixtures with the help of separation flask. Isn't it? The separate mixture of two immiscible liquids are going to be separated by separation flask or a separation tank we are going to use, and also we discussed some of the another two methods of the separation in the last session. Now in this session we are going to continue another two types of the separation methods which we are going to use in nowadays. So another one method of separation here, separation of two miscible liquids by distillation process. We are going to discuss here the separation of two immiscible liquids by distillation process, one it is, and another one is, as we know already, in our environment our air has some of the gases. How we are going to separate the gases, this mixture of air, how we are going to separate the gases from this mixture of air? So that will be with the help of separation of gases by the air by fractional distillation method, and also we are going to study what is crystallization here. So now study one by one the separation of two immiscible liquids by a distillation process, or a separation of two miscible liquids by distillation process. So this distillation process, it is used by our ancestors in our olden days to filter the wines, old wines. They are going to use to filter the wines with the help of this distillation process. What we are going to make here is, so I am considering the separation, this method with an example. We are going to separate the mixture of acetone and water. We are going to separate the mixture of acetone and water here. So how we are going to make the activity, how we are going to separate the acetone by the which present in the mixture of water? See here, take a separation tank. See, it is one type of the tank which we are going to use to used in the separation of the mixtures by the distillation process. Take this pot and you have to, so take the mixture of acetone and water in the flask, and you have to arrange the instruments as shown in this figure. You have to arrange the instrument as shown in this figure. When you are going to next, you have to heat the mixture of acetone and water. When you are going to heat the mixture of acetone and water, acetone has the very low boiling point than the water. Acetone has very low boiling point comparatively the water. When the acetone gets boiled, it will be evaporated, and the evaporated acetone will comes through this instrument, this compartment. When this enters to this compartment, what happened here? So in this process, which methods we are going to use is mainly it is evaporation and the condensation process. With the help of the evaporation and condensation process, we are going to separate the mixtures. Is it clear? We are going to separate the mixture to miscible mixtures here. So in last session we studied only how we are going to separate the two immiscible liquids, but here we are going to separate the two miscible liquids. What happened here? We are going to heat the mixture of acetone and the water. Here acetone has the very low boiling point than the water. Therefore, when we are going to supply the heat to the mixture, the acetone which is present in the mixture of acetone and water get boiled very quickly, and it will be evaporated. That evaporated acetone enters into this chamber, but in this chamber what we are going to do here is, we are supplying the cold water. Here is the cold water will be supplied and it will be out. So when the gases of the acetone will enters into this phase, what happened here? It will be in the form of bubbles, that is in the form of gas. When it is enters here, due to the cold water which is present around this chamber or this pipe, the acetone which is present in the form of the gas will be liquefied, will be converted into liquid, and will be get the pure acetone in the form of liquid in another side of this chamber. Is it clear? What happened here? In the first process, the evaporation of the acetone takes place. In the middle chamber of this distillation flask, what happened here? The evaporated acetone will be condensed. that will be condensed and converted into a liquid, and we get a pure acetone here. Is it clear? So it is another one type of the separation of the two miscible liquids by using distillation process. So this distillation process will be utilized in medical industries to get the required desired liquids or a desired, that is medicines, from the mixture of medicines. Have you clear? So and also we are going to use this method, distillation process, to get the pure water, distilled water. We are going to say the distilled water. So that distilled water will be comes from the distillation process. Have you got understood? So what happened here? It is a very simple. We are going to take the mixture of acetone and water in a one glass. We are going to heat the acetone and mixture of acetone and water. Since the acetone has very low boiling point compared to the water, so it boils very quickly and evaporates. That converted acetone gas will be enters into the chamber that having the supply of the cold water. That will be when the cold water will be comes in this chamber. In this chamber the gaseous molecules of the acetone will be passes from the boiled mixture of the acetone and water. When they are comes into this chamber, it will be cools. Why? Because we are supplying cold water through here, so it will be cools and condensed and converted into a liquid acetone and get collected into another pot. So we are going to separate the miscible liquids like acetone and water by the distillation process. Are you clear? It is clear? Yes. So this, what is the application here? This method will be utilized in the separation of the some of the medicals or some of the what we are going to say, some of the liquids which we are going to use in the medicines. Is it clear? So now I am considering another one separation method, the separation of the gases by the air. As we know already, in the air we found that large number of the gases, it is 10 to 20 gases are present in the air. So how we are going to separate the gases from the air? It is by the distillation process. So in the distillation process we are going to arrange the mode in this step. You have to see here in this step we are going to arrange what here. In the first we are going to have here is, it is a pressure compartment. We are going to increase the pressure here, and here is the, here we are going to decrease the temperature. It is the another one compartment, and here again when the air will becomes here, the liquid air will becomes here, again we are going to increase the temperature, and last finally we get different gases. How we are going to separate the gases here? See what happened here. So, as we know already, the gases will be liquefied by applying more pressure and lowering its temperature, decreasing its temperature. Applying more pressure and decreasing temperature, we are going to convert the gases into liquid, isn't it? So that method will be utilized here. We have to pass the air to the pressure chamber. Pressure chamber increases the air pressure and it will be moves towards next chamber. In this chamber what we are going to see here is, the air will be, when it is enters to this chamber, we supply the cold water from in this chamber. So when the cold water comes here, the pressure of the air will be increased by the pressure chamber. When it enters to the second chamber, in this chamber due to the cold water, the temperature of the gases will be decreased. As the pressure increases, as the temperature decreases, the gases will be converted into liquid. They will be liquefied here, and then that liquefied gases then again enters into next chamber. In this chamber it contains one separator here. In this separator the carbon dioxide, it will be removed from this separator and it will be enters into another chamber. So when it is enters into this chamber, it is nothing but the distillation chamber, fractional distillation chamber. In this chamber we are going to again heat, we are going to increase the temperature of the gases which comes from the separator chamber. When enters to this chamber, the gases will be, the temperature of the gases will be increased by giving the heat. When the temperature of the gases here increased according to the temperature, so some of the gases will be comes out. So according to the boiling point or according to the evaporating point of the gases. So how we are going to increase the temperature? According to their temperature, some of the gases will be evolved here. The nitrogenous gas will be evolved, and the argon gas will be evolved, that gas will be evolved, that can be collected separately, and oxygen gas. So then again oxygen gas removes here, it is a heavy compared to the oxygen, it is heavy compared to the argon gas and nitrogen gas, and will be collected in another one chamber. So by using a separation of a gas by fractional distillation method, we are going to separate the air, which the gases which are present in the air. Is it clear? It is another one method which we are going to use to separate the gases which are present in the air. Next I am going to discuss here crystallization. What is the crystallization here? We are going to separate the salts by making its crystals. Is it clear? Crystallization, it is a process of separation of the salts from its liquid by crystallizing. It is known as the crystallization process. So what are the application of the crystallization? The crystallization process, it is used in the separation of the crystals of the alum from pure samples. So separate the alum crystals, potash alum crystals, we are going to use crystallization process. These are all the methods of separation which we are going to use to separate the mixtures. Is it clear? So it is all about the mixture part. In the first session I discussed about in the matters having two types. One is the mixtures, another one is a pure substances. So it completes the mixture session here. It will complete the mixture part. Now we are going to study about the pure substances. What are the pure substances? So we are going to continually study here. Pure substances. Next we are going to study about the pure substances. What are pure substances? So students, now I am discussing the another one part of the matter, that is nothing but the pure substances. So as I told already, what are pure substances is a substance which is made from a single component. It is called it as a pure substance. So that pure substances are further classified into elements and compounds. It has two types, that is elements and compounds. Now I am going to discuss what are elements. What are elements here? So what are elements? The first time the scientist named called Antony Laurent Lavoisier defines very scientifically what is meant by elements. What are elements? What he defines that elements are the basic form of a matter that cannot be broken down into simpler substances by a chemical reaction. So what are elements here? Elements are the basic form of the matter. These are the basic form of the matter that cannot be broken down into simpler substances by the chemical reaction. So remember here, what are elements? What is element here? The elements are the basic form of the matter that cannot be broken down into simpler substances by a chemical reaction. So these are the basic form of the matter that cannot be broken down into simpler substances. For example, I am taking here the gold, it is one type of the element. Silver, oxygen, it is also one type of the element, and carbon, it is also one type of the element. Carbon dioxide, it is not an element, it is a compound. Carbon, it is an element. Here to understand, oxygen, it is an element. Hydrogen, it is an element. Oxygen, it is an element. Water, H2O, it is a compound. So element, it is a pure form. That is what are elements here? Elements are the basic form of the matter that cannot be broken down into simpler substances by a chemical reaction. For example, so silver, gold, aluminium, isn't it? So iron, so nitrogen, oxygen, sodium, these are all the elements. So now these elements are going to be classified into two types, that are metals and another one type is non-metals. What are metals? What are non-metals? We are going to study with the help of their characters, metals and non-metals. So metals are basically lustrous. Metals has the lustrous property. What is a lustrous property? When you are going to cut the metal, the freshly cutted surface has the shiny property, isn't it? If you have to take a rod, it may be any old rod you can take. You have to cut it using a blade or anything. You have to observe at the cutted surface that will be very shiny. That is nothing but the lustrous. But the non-metals are non-lustrous. They are not shining. except diamond. Diamond has the shining property, but diamond it is comes under the non-metals, but it has also the shining property. It is an one exception here, but all the metals have a luster property, and all the non-metals has the not has the luster property except diamond. So next property of the metal, it is sonorous. So when you are going to hit the metal, when you are going to hit any metal, it comes a different sound, isn't it? The metal sound, that is nothing but the sonorous, that is means by the sonorous. Metals have the sonorous, that is have a different sound, but the non-metals doesn't has the sonorous property, isn't it? They doesn't have any sonorous property. For example, for the lecture I am taking any example, iron, silver, gold, anything you have to take metals. So but for the non-metals, wood, it is also one type of the non-metal, isn't it? You can take anything here. Next, another one is metals are the good conductor of heat and electricity. Metals are the good conductor of heat and electricity. Yes, as we know already, we are using them wires that are made by the metals. It may be a copper metal, it may be aluminum metal. All the metals are the good conductors of the heat and electricity. But all the non-metals are the bad conductor of heat and electricity, except graphite here. Graphite will be it is also conducts the electricity. So except graphite, all the non-metals are the bad conductor of heat and electricity. They doesn't conduct electricity and the heat. Next, the metals has the ductile property. What is ductile property? The metals can be converted into a thin wire. We can convert the metals by beating into a thin wire, but we can't convert the non-metals into a thin wire. Is it possible to convert a stick or any wood particle I am taking, wood material I am taking, is it converted into a thin thread? No, it is not possible. So metals has the ductile property to convert it into a thin wire. That is called it as a ductile property. Metal shows the ductile property, but non-metals doesn't have a ductile property. Next one, it is malleable. Metals has the malleable property. Malleable property means it can be converted into a sheets like structure, paper like structure. Metals can be converted into a paper like structure, but non-metals doesn't convert. Can be converted into a paper like structures. Next, so all the metals are the hard. You have to remember here, all the metals are very hard. For example, you have to take iron. It is a very hard. It is a very hard material. Gold, any material you can take. It is a hard material, metal. But except sodium and potassium. These sodium and potassium are the two metals. They not hard. They are very soft. Even if the sodium metal and potassium metal, that can be cut by a scissor, that can be cut by our hand very easily, because they are very soft. It is one of the exception thing here. All the metals are the hard except sodium and potassium. Sodium and potassium are the two metals. They have the soft nature. But all the non-metals are the very soft. All the non-metals are the very soft. One exception thing here, the diamond. Diamond, it is a non-metal, but it is a very harder material in our universe, isn't it? The very hardest material in our universe, it is nothing but it is a diamond. So it is a non-metal, comes under the non-metal. It is one of the exception. All the metals has the hard nature except sodium and potassium, and all the non-metals has the soft nature except diamond. It is one of the exception. And another one property here, all the metals are the oxidizer. These are oxidized. These are used as the oxidizer. Metals are the oxidizer, and all the non-metals are the reducers. In chemical reactions which we are going to take the metals, the metal oxidizes the oxygen but when we are going to take the non-metals in a chemical reaction, that will be reduces the oxygen. Is it clear? So metals are the oxidizers and non-metals are the reducers. These are the main properties of the metals and non-metals. You have to remember here in your examination, maybe 3 to 4 marks questions should be asked on this. What are the properties of the metals and non-metals? Or differentiate the metals and write the differences of the metals and non-metals. So you have to write down here. First it is the characters, luster, sonar, these are the characters. Metals have these characters, but non-metals doesn't have these characters except some of the metals and the non-metals. It is all about the elements I am considering here. So another one part of the pure substances are nothing but the compounds. What are compounds? So this is all about the the pure substances. Under that elements, and so under the elements we are going to discuss here the metals and the non-metals, the properties of the metals and the non-metals. What are their properties? The lustrous, sonorous, conductors of heat and electricity, ductile, malleable and hard, and also oxide. So another one part of the pure substance, that is nothing but the compounds. What are compounds? Compounds is a substance composed of 2 or more elements chemically combined with one another is in a fixed proportions. What are compounds? Compound is a substance composed of 2 or more elements in a chemically combined state in a which ratio in a fixed ratio. So what is this means? That is, these compounds are nothing but these compounds are made up of 2 elements. I am taking hydrogen, it is a one element, oxygen, it is another one element. The chemical mix up of the hydrogen and oxygen, we get the water. So but in the what ratio? In a fixed ratio. I am considering here H2O, it is a compound, it is made up of 2 materials or the 2 elements, that is nothing but hydrogen and oxygen. What is the ratio here? That is 2 molecules of the hydrogen when combined with the 1 molecule of the oxygen, we get the water. Therefore in a fixed proportions, when the 2 elements are going to be combined chemically in a fixed proportion, that we get a compound. So compounds are nothing but the combination of 2 or more elements in a fixed ratio in a chemically, or the compounds are the compounds which are made by the 2 or more elements when they are combined chemically in a fixed proportions. Example for the compounds are nothing but, first I am taking here water. Water is made up of 2 elements, that is hydrogen and oxygen. Another one example I am taking here H2SO4, that is sulfuric acid. In this sulfuric acid, what is the ratio here? The 2 molecules of the hydrogen, 1 molecule of the sulfur and 4 molecules of the oxygen combined together made a compound called sulfuric acid, that is nothing but the H2SO4. Like that we are going to make some of the compounds in a fixed ratio. Is it clear? So compounds are nothing but these are also the mixture of the elements in what manner? In a fixed proportions, isn't it? So what is the difference between mixture and the compounds? Compounds are made up of 2 or more elements chemically combined in a fixed proportion, but mixtures that are the physical mixtures, that are the physical combination of the 2 materials that we are going to consider. For example, I am considering here water, it is a compound, but the sugar solution, the solution of the sugar when it is dissolved in the water, that is a sugar solution, that is a mixture. The difference between mixture and a compound I am taking here. If you are going to take a compound it is a water, but when you are going to take a sugar solution, it is a mixture, because it is a physically combined. In a water, 2 elements are chemically combined. Is it clear? So in the water, the molecules are in the fixed proportion, but when you are going to take a sugar solution, these are not in the fixed proportion. Is it clear? So this is all about your another one chapter is matter around us is pure. So in this chapter we studied what are the things we have studied, what is the pure metals, so what is the pure substances, and what are impure substances, that is called it as a mixture. What are the types of the mixture? Heterogeneous mixture, and homogeneous mixture, and also we studied suspensions, colloidal solutions and their properties, and also we studied some of the methods to separate the mixture. And today's session we discussed about the pure substance, types of the pure substance as elements, and the classification of elements as the metals and the non-metals, and also we studied about the compound. So in next session we are going to continue your next lesson. So this completes your another one important lesson, that is nothing but the is matter around us pure. Thank you.